In this video, you're going to learn how to correctly handle authentication in React when it comes to JWTs, access tokens, and refresh tokens. We're first going to start with some theory, really trying to understand and get the mental model of how these things work and specifically how they work within a React application. And then I'm going to show you some actual code so that you get to see how this actually looks like in a real React application and hopefully learn from it and then apply it to your own projects, right? Because this is important. Authentication is crucial for a good and secure React application. If you don't get authentication right in your application, you're going to ship security vulnerabilities and your user's data is going to be at risk. Some attacker can actually get your user's data, and that's never a good time for anyone involved. So really pay attention, watch until the end of this video, and try to really grasp these concepts because they are super, super important. Cool, let's get into it. So over here, we have your typical kind of traditional end-to-end lifecycle when it comes to a React application and all the different things that are involved. For example, over here, we have the user who's actually using the React application, right? The user is going to interact with your application. Maybe they're going to click a button, they're going to type on an input, they're going to visit a page, whatever they do, they are interacting with the React application. The React application takes those interactions and then converts them into requests to the actual server. Usually there's a server, and then the server is going to receive those requests, is going to process them, and then return a response back to the React application, either a success response or an error response. And then the React application is going to take that response and then re-render and show the updated UI to the actual user. Right, so in a nutshell, this is kind of how a React application usually works. Of course, there are exceptions. You're not always going to have all of these things in the same way, but for the most part, this is how it works. Now, for this to work properly, the server over here actually has to know who the user is that is actually sending the request. Because the user, first of all, they're not talking directly to the server. They're talking to the server through the React application. The React application in this case is kind of acting as a middleman between the user and the actual server, taking the user's inputs, transforming them optionally in some way, sending them to the server, and then taking the server's response and actually showing that to the user. The server in this case is not just going to send any response to any request that it gets, right? That's not usually how this works, right? You're not going to send data from your actual database to anyone that asks for it. Usually you're going to require that you know who the user that's asking for the data is, because sometimes you might want to know at least that they're authenticated, that they're signed into the application so that they can actually access it, or in some other cases, which is pretty common as well, that they have the correct permissions to actually get and read and do things with the data, that specific entry that they're trying to access. And all of this falls under the concept of authentication, identification, or even verification, right? The server has to authenticate every single request, has to know who is requesting the data, and then it has to identify that user, identify their permissions, verify that the user can actually do what it's trying to do. And then if the user can, it's going to return a success response. If the user can't, it's going to return an error response. And then it's the job of the React application to return those responses to the user in the form of re-rendering. Right? It's going to re-render the UI, the user is going to see something on the screen, and then the user is going to be able to take appropriate action. Now, for all of this to work, we're usually going to use JWTs, right? So let's put here JWTs. JWTs are JSON Web Tokens. If you're not familiar, you can just Google JWTs and see the first link that pops up. It's a JSON Web Token. It's essentially a token that is encrypted that can store data on a specific user and can be used by the server to actually validate if that user is valid, if that request is valid or not. JWTs, you can set data within them. They're all encrypted, so it's safe to actually transmit around. And you can also set expiration dates, which will allow you to expire the token after a certain amount of time and require the user to re-sign in to re-get a new token before they can proceed making more requests to the application. It's essentially a security measure, and these tokens are pretty much the standard in authentication in today's world. Now, in the context of our React application over here, we're going to have two of these tokens. We're going to have something that is called an access token. So we're going to do access token, and then we're going to have something that is called a refresh token. These tokens over here are going to be used either by the server or by the React application to essentially identify and authenticate the user and then allow the user to make requests to the actual server. These things over here, these access tokens and refresh tokens, which are both JWTs, by the way, so both of these are JWTs, are going to be used within this process to actually create a successful and robust authentication for any given user in any given application with any server. So how does this work? Well, let's start at the beginning. Let's consider the initial stage. At this stage, the user is not authenticated. The user maybe opens the app for the first time and they're not authenticated. Then they're presented with a sign-in form because let's say that the React application requires them to be authenticated to have an account before they can do anything. So they're going to have a sign-in form. In that form, they're going to fill out the form, enter their email, their password, whatever. And then that's going to be an interaction. That's going to then send a request when they press submit. And that's going to make a request to the server to actually authenticate and log into the application. The server is then going to receive that request. It's going to get the credentials from the user, the email, the password, make some check that they're correct in the correct shape. Then it's going to look in the database, see if there's an actual user with that email and if the password is correct. And only if everything checks out is the server actually going to consider the user logged in. And in that case, the user is going to do two things. It's first going to take some data from the user, maybe the user ID, maybe an email, maybe something else altogether. It really depends. It's flexible. And it's going to create a refresh token from the user using that data. That refresh token, the server is never going to send to the front end. This is a very, very secure token and should never be leaked to anyone outside of the server. The server, what it's actually going to do is, let me make an arrow here. It's going to store this in an HTTP only cookie. So let's do HTTP only cookie. This means that, let me just make here so we have a little bit of space. This means that this is a cookie that cannot be accessed by JavaScript, which essentially means that only the server is going to be able to set this cookie and only the server is going to be able to read this cookie. The React application or any other JavaScript code that might be malicious code by some attacker can never read the secure token because it is in an HTTP only cookie. This is the first layer of security. Then the server is also going to take either, again, some data from the user, or it's going to take that refresh token and it's going to generate from that an access token. So let's make an arrow over here. It's going to generate an access token that is then going to send through the response back to the React application. And the React application is now going to be in charge of storing and managing this access token. This access token over here is going to be the key that is going to allow the user to essentially authenticate against the server. And this token has to be passed along every single request that the React application makes to the server, because that is what identifies who the user actually is. Remember, this access token was created from the refresh token, which was created by some data from the user. And that's how we can uniquely identify the specific user. As long as we have a valid access token, we can make requests in our React application on behalf of the user, and those requests are going to get validated on the server because this is a valid access token. Now, here's the thing. Remember that we have these JWTs, which access tokens and refresh tokens are. We said that we can put expiration dates on these access tokens, and we usually want to do that for security. And what I'm going to do here, I'm going to show you the typical expiration date for a token. So for an access token, you're usually going to want to do something very, very short. For example, like 15 minutes, like so. That's how long this access token is going to be valid. After 15 minutes, this token is not going to be valid, and then we're going to need to have a new one for the user to be able to keep interacting, authenticated with the application. The refresh token, however, this one, because we're only storing it on the server and in an HTTP only cookie, which is a secure cookie, we can get away with having this expire after a bigger amount of time. So we can do something like 30 days, for example, right? Doesn't have to be 30 days. It can be 60, it can be 15, it can be 90. It really depends on your use case, but generally 30 days is a pretty safe average that we can implement for this example. Now, with these two tokens, we actually have everything that we need to, first of all, authenticate the user and then keep the user authenticated. So this is how this works. This refresh token is essentially the last source of truth. This one, remember, only stays on the server, never goes on the client. As long as this one is valid, which for now we said is going to expire after 30 days, we're going to consider the user to be authenticated. Now, this access token, where do we store it? Where you might initially think that you want to store this in local storage, right? Or even maybe in a cookie. But I would advise against that because that is not secure. Remember, everything that you store in a cookie or in local storage through your React application, which really is through JavaScript, an attacker can also access as well. They can write the same JavaScript code to check your cookies to get the token, or to check local storage to get the token. I would not recommend that you put this token inside of local storage or inside of a cookie because it can be accessed by JavaScript. So where do you put it? Well, the safest place to put this token is to put it in memory. That means in the context of a React application, in state, right? That is state that is only local to this React application, that lives inside of the memory of the actual computer, the process that's running this React application, right? So let's come here and let's make a little text here and let's say in memory. I'm going to put here state just so that we know that this is in state. We're going to store this in memory in state so that no JavaScript can actually access this, because it's a lot harder to access a computer's memory than it is to access the cookies or the local storage. Putting it in memory is safe enough, and when you add the fact that this expires after 15 minutes, you're doing a lot to actually make the security of this token and to prevent any unwanted attackers from actually getting this token, right? Again, it's much easier to access, it's much harder, sorry, to access this token if it's in memory, if it's in state, than it is to access it if it's in local storage or if in a cookie. But then you might ask yourself, well, if this token is in state and it also expires after 15 minutes, what happens when the user refreshes the application? Or even what happens after 15 minutes? What do we do with this token? Well, this token, first of all, is the responsibility of the React application. The React application receives this token from the actual server, and then it is responsible for storing it in memory, and it is also responsible for handling the case where this token actually expires. Right, so let's think through an example. The user signed in initially to our application, right? They filled in the sign-in form. We sent that interaction through the React application as a request to the server. The server authenticated the user, created a refresh token, stored it in an HTTP only cookie, and then generated also an access token, send that to the React application, and we put that token in state. What happens if the user either refreshes the application, refreshes the browser window, or if 50 minutes have passed since we generated that initial access token? Well, in that case, if the user refreshes the application, we're no longer going to have a token, so we're actually going to send undefined as a token to the backend. Or if you still have a token but it's expired, we're going to send that token, and the backend is going to realize when it tries to verify the token that it's expired. In any way, we're going to have a token that is going to fail the validation check on the server, and then what the server is going to do is, instead of logging the user out directly then and there, it's first going to check the refresh token in the HTTP only secure cookie, and if there is a refresh token there, it's going to try to validate it, and if it's valid, it's going to generate a new access token and then send that through the response to the React application, and the React application is going to store it in memory once again. Right, and then the React application is going to take this token and then send it along every single request once again, just like before. That is going to work until the user refreshes the application or the token expires after 15 minutes. And after that, we're going to do the same thing again. The server is going to check this refresh token again. And if it's valid, it's going to revalidate the actual access token. And the reason why we do this is because we don't want to sign the user out every single time that this access token gets expired, because that would be a horrible user experience. We use this for security and for convenience. And then we have this as a backup, as the single source of truth of the actual user authentication status, right? So again, as long as this is valid, we're always going to be able to regenerate an access token and store that in memory as well. And I mean, that's really it, right? This is in a nutshell how authentication works with JWTs, right? The server is only responsible for this refresh token and generating the access token, but it's really responsible for keeping, storing, checking, and verifying this refresh token. The React application is only responsible for this access token, and we're storing it in memory, in state, not in local storage, not in a cookie, and this is a pretty safe bet for this access token. And then the user, through this mechanism, can interact either with this access token or using this refresh token that gets regenerated from the server, and actually be authenticated and identified against the server, so the server always know who the user is that's making every single request. This is how this works. So now that we have this and now that we understand this, let's quickly look at some code to see this in action and see how you would implement this in an actual React code base. All right, so over here, we have a simple authentication provider component from another application that I have that really illustrates how all of this works. So the authentication provider component is responsible for everything related to the actual token and sending the specific request to the server to actually authenticate the user. So as you can see here, we have a state variable for the token that is exactly the access token that I talked about here. This lives in state inside of this component, which is going to be handled by the processor's memory of the actual computer that is running this React application. Then over here, we have a use effect that runs once on mount, and it essentially tries to fetch the actual user from api.get/api/me, and then it's going to get the response.data.access token and then set that in the state. If we don't have a token, so if the user is not authenticated, we're going to set the token to null, and this gets used by the rest of the application to determine if the user is signed in or not. Actually, if we have a token, if it has a value, the user is signed in. If we have a token of null, it means that we check checked the backend that we sent this request, but that there's no token, so the user is not signed out. And if the token is actually undefined, which is its default state over here, we haven't provided any default value, so it's going to be undefined. That means that we haven't fetched the token yet, and then we should throw a loading state to the user and let this run, and this is going to actually set the token once that this request has finished. And then over here we have a use layout effect, and I'll get to why we're using use layout effect versus use effect in just a moment. But essentially this is creating an interceptor for the actual request. So we're doing API.interceptors. This, by the way, is using Axios as a fetching library. So we're adding an interceptor on the request, and then all that we're doing is we're checking here if we have a token, right? If we have a token, we're actually adding that token in the headers, in the authorization headers of the request. And if we don't, we're just passing the authorization headers that were there before. This is actually has the job of taking the token, this runs whenever the token changes, to actually put it and inject it into every single request. So going back here to our actual thing, this is taking this access token and putting it in every single request automatically to send to the actual server. This is going to run initially once on mount. So we're going to do this, and then every time that the token changes, which is why we put it here in this dependency array. And the reason why we're using use layout effect as opposed to use effect is because we actually want this to block the rest of the rendering, because other components further down in the component tree are actually going to trigger requests, and we want to guarantee that this code over here, this interceptor, is put before any of those components actually trigger any requests. So that's why we're using use layout effect versus use effect. Now over here, we have an actual helpers file for the API, and we have this with auth function over here that essentially wraps every single request that needs to be authenticated. And this one, all that it does is it just checks if we have a token from the config.headers.authorization. And if we do, it's going to try to verify it. Otherwise, it's going to make verified as false. This verified token just receives the token, and it's this function over here. I'm using the Jose, whatever you want to spell it or pronounce it, library to actually have a token. This, by the way, all runs in the front end because this was an example that I used actually, but typically you would do this inside of a server environment. So this is not totally accurate, but still it does the things that it's supposed to do. It actually tries to verify the actual token and just returns either true or the actual payload, because again, we said that these tokens can optionally have payload of a specific user. And in this case, I was using the payload to identify who that user was. So then we're calling that, and we have this verified variable over here, and then we're just checking if verified is true. If it isn't, then what we're doing is we're returning a 403, so forbidden, that is the status code for forbidden, and a message of unauthorized. Otherwise, we're just going to call the actual request because this user is authenticated and we've done this check. This is a convenience helper to wrap every single request that is done in the application that needs to have authentication to essentially not have to repeat this code over and over again. We just want to put this as a wrapper to any function, and this will take care of checking the user's authentication. And then if we go back here to the auth provider, we're actually using that over here in this use layout effect. So this we're creating again using use layout effect because we want this interceptor to be there before any other component continues rendering. And this one, we're just doing it on the actual response. This piece of code over here is essentially handling the case where we either no longer have a token or this token is expired, and we try to send it through an interceptor, through this initial interceptor over here on the request, but the server said, hey, this token either isn't there or it's expired, so it's no longer valid, but I have a new valid refresh token, so here's a new access token for you that you can use to re-authenticate your user. That is what this piece of code, this use layout effect over here, is doing. So this, as you can see, we're putting an interceptor on the response as opposed to the request as we did over here, and then we're just doing nothing with the response, but we're only checking if there's an error. And let me remind you that if we run this piece of code over here, this is going to result as an error inside of Axios. So that's why we're doing the error. And what we're checking is we're first storing the original request from error.config in a specific variable. And then we're checking the error.response.status, making sure that it's 403 and that we have data.message that is equal to unauthorized, which again are these values over here, 403, and then message unauthorized. And if that is the case, then we're in a situation where this user hasn't been authenticated. The server said, hey, you're not authenticated. This access token is not valid. I can't fulfill this request for that user. In that case, instead of, as I said, signing the user out then and there, we first want to make a check if the actual refresh token is still valid. So over here, if that check passes, right, 403 and unauthorized, we're trying to create a new response and doing api.get/api/refresh token. That is going to refresh the token of the actual user. Then if we have an actual token, response.data.access token, we're setting that token in the state. Again, we are replacing the existing access token that was there before with the new access token that we just gotten from the API/refresh token endpoint. And then we're doing original request. So this original request that we tried to fire initially that resulted in this error, this 403 error, because the access token was no longer there, we're adding that token inside of the headers of the authorization. We're doing that over here. And then what we're doing here is we're adding this custom property ._retry equals true. And the reason we're doing that is because remember, this over here is going to run every single time this token changes. And here we're actually setting this token to change. And essentially, we don't want this to override the token that we're setting over here in this use effect, in this use layout effect. We're putting retry true because this is a request that is being retried. And over here, if you notice, we're checking config._retry. And only if retry is not there are we actually setting the token. Otherwise, we're putting the token of whatever was there initially in that request. And then with that, the only thing that's left to do is return API and then call the original request over here. So what we've done is we first sent this token to the actual server. The server said, hey, this token is no longer valid. That's fine. Then the React application intercepted that response, checked if it's an actual response from our server that says unauthorized, and then we're trying to actually refresh the token by sending a new request. And this is all happening, by the way, the user has no idea. The user thinks this is just one request, but actually this is now the second request. And then if we have a new access token, then we're setting it in the state again to be used in further request through this use layout effect over here. And we're setting it in the original request. We're setting original request.retry true, and then we're returning, so refiring the original request, but now with the new updated access token, which should clear with the backend because the backend just gave us this token. Now, if that doesn't work, if this refresh token is expired or something happens to it, then the server is actually going to throw an error over here, which we catch because we're inside of a try catch block. And if we have an error, we're essentially setting the token to null, which again is going to tell the rest of our React application that the user is no longer authenticated and that we should present them with a sign-in screen. This is how you implement all of this that we implement visually. This is how this would look like in a simple React application. Obviously, your implementation might differ. You might have different variables over here, but this is essentially the concepts and the mental model of how you would take everything that we talked about over here, the access token, the refresh token, the user, the React app, and the server, put them all together, make it really secure, make it as seamless as possible to the user. If this passes, the user is just going to think that its request took a little bit longer than usual. It will have no idea that we had more than one request. And if we get over here to actually setting the token to null, the user is just going to be signed out and it's not going to be a terrible user experience at all. Right, so with this little piece of code that I've just shown over here and this little mental model and this illustration, you should have everything that you need to go and implement this in your own applications and integrate this into whatever code is existing, whatever backend you currently have, right? Maybe you also have something like a third-party provider that does authentication for you. In that case, they would probably do a lot of these things themselves, and you would use maybe some SDKs or some components from them to actually authenticate your user. But if you're working in a situation where you have to implement some of this or all of this yourself, now you know how to do it, you know and understand the mental model, and you also know and understand the code of how you would actually go about implementing something like this in a React application. So there you go. I really hope that you've enjoyed this. And if you did, please leave this video a big thumbs up. There's going to be more videos like this coming in the future. Also, you can click here to subscribe, or you can click here to watch a different video of mine, which YouTube seems to think that you're really going to enjoy. And with that being said, my name has been Darius Kozdan. This is Kozdan Solutions. Thank you so much for watching, and I will see you in the next video. Ciao, ciao.